Algebra 2, Lesson 2-3, factored form of a quadratic function. So the factored form of a quadratic function, if you need a little practice on your factoring, my preferred way to do it is really trial and error, guess and check, whatever you want to call that. So if I have an 18 here, what are my numbers that multiply to 18? I either have 1 and 18, 2 times 9, or 3 times 6. And then when you look at those, which one adds up to give you this middle term? And so the 3 plus the 6 would be the 9. So those are the two factors I would need to use. Now in this case it's a little bit easier, but just because of the fact that everything was added. However, let's see if I can create one without messing up here. If I had x squared minus 3x plus the 18, how would that work? So, hold on, I already messed up. I want a minus 18, I think. So I've got a 1 and an 18 still, a 2 with a 9, or a 3 with a 6. But since I have a negative 18 right here, I'm going to have to use a positive and a negative. And when you do that, if one of them is positive and one's negative, and when you add them together, you're going to actually be subtracting. So which of these three, when subtracted, is going to give me a 3. So the 3 and the 6, and it's the bigger number needs to be negative since this is negative. So I would put my 6 here, my 3 there. There's my positive 3x. There's my negative 6x. So when I combine them, I get the negative 3x that I need in the middle. So factoring quadratics. However, what's going to happen if you have a number in front of your x squared, a coefficient out there? There's a couple different ways to do this. A lot of people use this method of factoring by grouping. You take the first term and the last term and you multiply them. So I've got a negative 30 there. And then I try to use the factors of the negative 30 to get this negative 7. So I've got 1 and 30. I've got 2 with 15, 3 with 10, or 5 with 6. And again, it's sort of like the last one where I wrote it down. Which of those two numbers is going to give me a 7 in the middle? Since it's a negative, and I'm going to be subtracting again because one's positive, one's negative. And so I'm going to have that 3 and 10. So then you write it out, the 2x squared, a 3x, and a 10x. And then the larger one needed to be negative because this was negative. So this 10 is like a negative 10. Make sure it doesn't look like it's just floating there. And the negative 15. We're going to solve this here in a minute, so we'll leave that equals 0 on the end. Then you group them together and you factor out common factors. So in this first one, the only thing they have as a common factor is the x. And in the second one, we want to get a 2x plus 3. So if I want this to be a positive 2x right here, I'm going to take out a negative 5. So negative 5 times what makes a negative 10? 2 and the x, and factor out a negative 5 from the negative 15. Positive 3. Then this factoring by grouping method says, if you notice here, these two are the same. So it's like we're going to factor that out, leaving the x and this plus a negative 5 or minus 5 for our factored form. After that, the next step is, since it is multiplied, this is multiplication right between here, and it equals 0, the zero product property says that either this one or this one must be 0. I mean, think about it. If you call the first one here A and the second one B, and you have these two things multiplied, one thing times another thing, the only way for it to equal the 0 is if one of those two things is 0. So then that's what the zero product property says. So let's go back and get that stuff out of there so you can actually see what we had. So either 2x plus 3 is 0, either 2x plus 3 is 0, or the x minus 5 is 0, and solve each of those, and that gives you your two possible answers. Subtract the 3 to the other side, I've got negative 3 equals the 2x, and divide by 2. Or add the 5 to the other side for your two possible solutions. These solutions right here then are like x-intercepts, or sometimes we're going to call them roots when we have imaginary, we'll get to that later, or zeros or x-intercepts. So what's that look like on the graph? So on the graph, there's a negative 3/2 over there. There's a positive 5 out here. This was a parabola because of the 2x squared opening up. If we wanted to find that vertex, remember the negative b over 2a we had in the last chapter? So that would be negative b, negative 7, would be 7 over 2 times 2, 4. So it's like a positive 1 3/4. Also symmetry would tell us it should be halfway in between these two x-intercepts. And then if we want to know the y value, we'd put that 1.75 in here, 1.75 in here, and then we would actually crunch that out, find the y value down here of a negative graph your parabola. I didn't actually crunch it out. I don't know what that number was, but it would be a negative number down there. You can go ahead and do it if you want to. I just was trying to get to review here. So if it asked you for the interval where this graph was positive, it would be those two arms right there. So positive. And so in this case, that would be forever to the left to negative infinity, up to that negative 3/2. The 3/2 itself is 0. 0 is not positive. It's not negative either. And then from that 5, that side of the arm here, forever to the right, these are the x values we're talking about here, the domain. So forever to a positive infinity. If we're talking about the negative interval of this graph, that would be this pink dip down below. So where that graph comes down below here, that would be negative. So it would be between the negative 1.5 or negative 3/2 up to that positive 5 for the negative part of the graph. If we wanted to do the increasing, decreasing part, just as a quick review, decreasing, as we moved from, if you're reading a sentence, left to right on this graph, we would be decreasing from the negative infinity up to the x value of the vertex, that 1 3/4. Again, right where you turn around, you're neither going down or up, so it's not included. And the increasing side of this graph, I don't know what I'm using here, increasing side would be, again, from the vertex here, going up when you move from left to right. So that would be starting from your 1 3/4 and going forever in a positive direction. Whew, that's a lot of stuff right there on that page. We could do this one over and do all the same things if you wanted to. The thing I was trying to emphasize here is the first step would be you had to move the 15 over to the left first. Hello, I didn't move it at all. Subtract that 15 over to the left. Now I have a slightly different method that I use for factoring these sometimes. You could, and that, it looks like this. So to get the 2, it's just a 1 and a 2. To get this 15, it's either 1 and 15 or 3 and 5. And I like to just write them down on the paper so I can see them. I'm going to have to multiply these two numbers here times one of the numbers over here each, and then add and subtract and see if I can come up with this -7 in the middle. And so by that, when you're trying them, what I'm saying is if I take this 2 times that 5, I get 10. If I take this 1 times this 3, I get 3. I can combine, adding and subtracting, the 10 and the 3 and get that -7. So by trial and error, just using these, I would also know that the 10 needs to be the negative. So these two numbers tell me the coefficients on my x's. So I need an x and a 2x. We kind of knew that because 2x squared, that's the only way to get that. Then the 2 paired up with the 5. So the 2 pairs up on the inside here. So the 5 would have to go here. And then the 3 paired up here with the 1. So the 3 and the 1 would pair up there. The 10 needed to be negative, so I've got to put a negative here to multiply the -5 times the 2 to get the -10. The 3 positive. And if I'm not mistaken, that's the same factors we got on the other page. So where do each of these using the zero product property equals 0? This one at 5. This one at -3/2, and then it's just the same as what was on the other page. All right, then the last thing is sometimes they will ask you to actually do some sort of an application problem usually on these, whether this is a baseball player hitting a ball, whether it's a golfer, whether it's volleyball, whether it's football, whether it's soccer, I don't know, whatever. But if they gave us this formula for the height of the ball at t seconds, so second t seconds is my x-intercept, the height over here in feet, so this is like feet. These t's represent seconds. And so the question that they usually ask on these is 2. So 1, what's the maximum height of the ball? Or 2, what's the time when the ball hits the ground? Now, a couple, you can always use a graphing calculator sort of thing or graphing tool like Desmos, and it'll put the formula in and it's going to tell you. But algebraically, how do you do this? One other thing is, how about could I use quadratic formula and it would tell me the 2 t's where it actually hits the ground here, and if it continued back over here, which is meaningless on the negative time because it never did touch the ground back over there. So, well, if we can factor this to find our one time here when it hits the ground, let's try that. So look at all these numbers. One of the first things whenever you're working on a quadratic you should look for is there a common factor? And I believe 4 will divide evenly into all of these numbers. So if I take that 4 out of all of these, that would leave me with a 4t. This would leave me, whoops, squared, 8t, and a 1. So 4, 8, and 1. That doesn't seem like it's going to be able to factor. So if it isn't factorable, then you would have to be left with using the quadratic formula in order to solve this. Whoops, maybe it was just that I copied. Let's put a 48 here. And then let's do this again so that we could factor. I don't want to use the quadratic formula. I was trying to demonstrate for you how to use your factoring. So let's take that out of there and use this equation. We're looking for when it hits the ground, so the height would be 0. I'm going to take that 4 out again. I'm going to take a negative 4 out. That way I don't have to deal with a negative on this t. So that will be 4t squared. 4 times 8 is 32. And 4 times 6 is 48. Except if I'm taking a negative out, those are... Wow. Gotta watch these signs. How about that? Now double check. Negative 4 times 4 would be negative 16. Negative 4 times negative 8 is 32. Negative 4. Well, that's not 48 over there. Good thing you stop and check your work. Man, I hope you don't make as many mistakes as I do. So then you would have this 4 times 12. Well, shoot, I still have a 4 that's a factor in there. I should have probably taken a 16 out to start with. Take another 4 out of all these. Well, that's kind of nice because now I can see the factors a lot easier. So you've got this negative 16. How about a t minus 3 and a t plus 1? If you're looking for the height to be 0 when it hits the ground, that would be a 0 for my answer, because this answer on the other side, the height, again, hits the ground at 0. So t minus 3 equals 0. That'd be at 3 seconds. And then the second one right here would end up solving to be t being a negative 1 seconds. And on your graph, that kind of makes sense right back over here. This would be a negative 1, but it doesn't really have any meaning in the problem. So that one wouldn't actually be used. If you're going to do any of your other, like your positive and negative intervals up here. So obviously the graph would be positive then, all the way up there. So my positive parts of the graph in this case would end up being from this was 3 seconds over here, I believe, that we found. So it hit the ground at 3 seconds, the height being 0. Positive would be from the negative 1 to 3 on the graph, but in the application of our problem, does this negative 1 actually exist? No. So I would say from the time the ball left the ground here, the height being whatever that is at times 0. So if you put a 0 into that problem, looks like I'd get a 48 out of there. So at 48, whatever inches, so starts at, well, that would be the height, but the time was times 0 up to time 3. The negative, in this case, it wouldn't ever have been negative in reality. If it was just an equation question, then you would include these other parts. Where is it? And how about the maximum height here? Remember, you do negative b over 2a to find the vertex. So in this case, negative b, negative 32, over 2a. 2 times negative 16 is negative 32. And so that would happen at 1 second. And if you wanted to know the height for that, when you put the 1 in here, that would be negative 16. And 1 in here plus 32. And then plus this 48. So those are 16 plus 48, it looks like 64 to me. So at 1 second, it's up at 64 feet. I did that kind of fast, kind of messy here, running out of space. It does kind of make sense though, that if you look at the graph, this -1 up to this one, that would be 2 seconds for symmetry on our parabola. And then from 1 to 3, that's 2 seconds also. So there you go. On a problem like that, where you have to sometimes do an application problem with it.